The overall goal of this methodology is to measure extruded catalyst bending strength and to predict how well catalysts resist breakage caused by either collision with a surface or stress in a fixed bed.
I originally had the thought that perhaps the rupture force in bending mode was the appropriate link to relate catalyst strength to the severity of handling of the catalyst to describe catalyst breakage.
The main advantage of this technique is that it measures how catalyst extrudates hold up to breakage in quantitative simulations of real-life events.
This technique accurately measures the length-to-diameter ratio of catalysts and therefore quantitatively measures the extent of the breakage caused by collisions or stress.
This method's evaluation of extrudate resilience to breakage in fixed beds can also be applied to other shapes, such as spherical catalysts.
The bending strength of an extrudate is difficult to determine without visuals because of the various stress regions during bending.
To begin the procedure, obtain at least 30 catalyst extrudates by riffling an appropriately thermally pre-treated catalyst sample of interest. Then, turn on and calibrate the bending test frame. Attach a 10 Newton load cell to the bending test frame. Once the test frame is ready to use, select an anvil speed of 0.2 mm per second and a 5 mm support span. Choose Modulus of Rupture and Maximum Force in the Results tab. Configure the test to end when the load force drops to a sufficient extent to indicate extrudate breakage. Fill in any required sample and specimen information and ensure the software is ready to start the test. Then, clamp a 5 to 6 cm diameter Beeckman funnel with